I am Dr. Ramya Swetha, Assistant Professor in Civil Engineering Department, Institute of Aeronautical Engineering. So today I am going to explain about Introduction to Open Channel Flows. In this open channel flows, the students will try to learn. This is the course objective which we have. That is the importance of study of open channel flow. So first, the students are going to learn what is the importance for understanding the open channel flow, where it is useful for us, and to give brief description on different types of flows and channels and hydraulic design principles of channels. This is the learning objective in this open channel flow. Next, course outcome. Once completion of the chapter, this topic, student will understand the student will able to understand the differences between the lined, unlined canals and uniform, non-uniform flows for the design of open channels. So as per Bloom's taxonomy level, it comes under understand level. So this is about course objectives and course outcomes which are relevant to open channel flow. So what is open channel flow? What is meant by open channel flow? In any terminology, once we are focusedly read that particular terminology, whatever we want, we understand. So that gives the something about we understand without any knowledge about that particular terminology. Once we focus that particular terminology, it gives some understanding about that particular thing. Like that, open channel, the name itself tells something about us once we focusedly understand that particular terminology. So coming to the open channel flow, the name itself tells something for us, that is open channel. It means the surface, the liquid surface is in free. So the definition of the open channel flow, the flow of fluid with a free surface. A free surface having constant pressure such as atmospheric pressure. This is the definition of the open channel flow. So open channel, the name itself tells something, it is to be open. It means as per our subject point of view, we are going to define as the flow of liquid which a free surface. A free surface is a surface having constant pressure such as atmospheric pressure. A liquid flowing at atmospheric pressure through a passage is known as flow in open channels. So in this particular chapter, we are going to understand how open channels are going to classified, how the way of the working style of each type of having its own advantages and disadvantages. In most of the cases, and one more important point, in most of the cases, the liquid which we consider in open channels as, we take it as a water. We are consider water as a liquid which is present in open channels. Flow of water through a passage under atmospheric pressure is called flow in open channels. So these are the various kind of definitions we may understand. The flow of water through pipes, coming to the pipes, till what we call open channels in at open free surface, that is called open channels. Now coming to the flow of water through pipes at atmospheric pressure. In coming to the pipes, it is a closed circuit. It's a closed one. But even though the flow is classified as open channel, why? Because the flow of water through pipes at atmospheric pressure are when the level of water in the pipe, in pipe, the flow of water, we are considering any type of pipe, the water is flowing in this level, not at the top. So the flow of water is like this and the pressure is atmospheric, such type of flow is also known as open. It comes under also, we take it as open channel flow. The flow takes under the flow whenever the level of water in the pipe is below the top of the surface, not edge, not at the edge. It's not complete. When how much the pipe is there, how much the water is not there, the flow is somewhat little bit low. It means this is also surface. Till the surface, the space is there. So water is flowing in the pipe like this. So this is free surface. Such types of flow is also classified in open channel flow. In case of open channel flow, as the pressure is atmospheric, the flow takes under the force of gravity. The flow takes place under the force of gravity, which means the flow takes place due to the slope of the bed of the channel only. In some of the cases, the pressure is atmospheric. The flow takes place under the force of gravity, which means the flow takes place due to the slope of the bed of the channel only. In this, one more important point, the hydraulic gradient line coincides with the free surface of the water. Hydraulic gradient line coincides with the free surface of the water. Open channel is particularly applied to understand the flow of a liquid in different types of availability is there. Artificial and natural flows. Artificial flows, natural flows. We can divide it into these types. So coming to the artificial, spillways, canals, weirs, culverts, ditches, drainages, these are all comes under artificial open channel flows. Natural open channel flow, naturally, where we understand, where we are considered as example, those are streams, rivers, floodplains. These are all comes under natural, example for natural open channel flows. So these two kind of flows are similar in many ways. There is no much difference between these artificial and natural ways of open channel flow, but differ in one important aspect. Open channel flow must have a free surface where pipe flow has none. This is the one of the variation between open channel flow and pipe flow. This is the this is the figure. We may understand open channel in better way. So coming to the open channel flow, this is the channel bottom. This is the channel bottom of the channel with the velocity of the flow. This is the velocity of the flow. Till here the water surface is existing. So the remaining is also there. It is comes under free surface. So this is the most important aspect. This is we consider as datum line. V1 and V2 are the velocities. The velocity between the two sections. Here we are considering two sections. This is section 1-1 and this is section 2-2. This is section 1 and section 2 of the channel. We are consider one channel, it is open. So in section 1-1 and section 2-2, in between velocity may vary or may not. It depends upon the situation of the channel. So the depths also. This is the depth of the water flow. This is the depth of the water flow at section 2. This is the depth of the water flow at section 1. D1 and D2. D1 and D2. So the remaining, this is the energy line. This is the loss of energy. So datum head, energy head, this is kinetic head. The relations between these we will see in our next videos. So this is the presentation. Little understanding about the open channel flow. This is the water surface. Till how much the depth water is there, till that we are considering. So this is the channel bottom. Now, next one is the classifications of open channel flow. So the classification in different ways, it depends upon the, we may classify in different ways. A channel in which the cross-sectional shape and size and also the bottom slopes are constant is termed as prismatic channel. When we are considering any channel, in that particular channel, the shape and size, also the bottom slopes are constant, such type of channel is termed as prismatic channel. Prismatic channel. Most of the artificial channels are man-made channels, are prismatic channels over long stretches. So coming to the long stretches, all man-made. What are the artificial channels we are understanding? Spillways, drainage systems. These are all, these type of artificial channels are, in most of the cases, those are all prismatic. It means the shape and size and bottom slopes are all constant. So in man-made channels, most of the channels are prismatic channels. Prismatic channels. So coming to the, based on the shape, the rectangular, trapezoid, triangle and circular are some of the commonly used shapes in made channels. So it depends upon the requirement. So the which type of channel we have to consider, it is depends upon the situation, and based on the design criteria we are adopted the particular type of the channel. So based on the shape, these are the different types: rectangular channel type, trapezoidal, triangular and circular. Coming to the natural channels, generally having very different types of cross sections, and consequently those are all non-prismatic channels. Natural channels like rivers. The rivers, once we are considering different types of 100 kilometers of stretch of or 10 kilometers stretch of any river, the depth varies and the shape of the river also varies, and the bed slope are also vary. So it means all natural channels are termed as non-prismatic. All natural channels are non-prismatic. So coming to the, based on the depth, the channel classified in two ways. If the flow of the depth or discharge at a cross section of an open channel flow is not changing with respect to time. With respect to time. As per the time point of view, there is the flow depth or discharge at a cross section of open channel flow is not changing with respect to time. Such type of flow is known as steady flow. With respect to time, there is no change in discharge at any open channel flow. Such type of flow is known as steady flow. Otherwise, it is called unsteady flow. It means unsteady flow means in any depth or discharge at any cross section of the open channel flow is going to change. Is changes with respect to time. It is going to change with respect to time. It's changes with respect to time. Such type of flow is known as unsteady flow. Coming to the flood flows in rivers and rapidly varying surges in canals are the some of the examples of unsteady flow. The discharge is changes over time to time, and that too rapidly in times of flood, at the time of the flood and different situations. So such type of flows are examples of the unsteady flow. Unsteady flows are considerably more difficult to analyze than the steady flow. When compared to the steady flows, it's somewhat difficult to analyze the unsteady flow because of the variations involved in the discharges as well as depths also. Now the next classification is uniform and non-uniform flows. Coming to the uniform and non-uniform flow, if the flow depth along the channel is not changing at every cross section for a taken time. So here we are considering such particular time. In that particular time, the depth along the channel is not changing at every cross section. Such type of flow is known as uniform flow. If the depth changes at every cross section along the flow direction for a taken time, such type of flow is known as non-uniform flow. A prismatic channel carrying a certain discharge with a constant velocity is an example of uniform flow. So prismatic channel carrying a certain discharge with a constant velocity is an example of uniform flow. This is the representation of different types of open channel flow. This is the normal depth. The depth at the section, both the sections, consider section 1 and section 2. In both the sections, the depth is normal depth. The depth is same. Throughout the channel, the depth is same. Coming to the steady gradually varied flow, the gradually varied flow. And coming to the rapidly varied flow. So in this also, the depth and the direction and the flow, the rate of flow are discharge. The rate of flow or the discharge along the depth, the uniformity, there is no change with respect to time. So coming to the unsteady flow. So these are the representation of different types of open channel flow. Non-uniform steady flow. The water depth changes along the channel cross sections but does not change with respect to time at every cross section. So for this, backwater surface profile at the upstream of the dam is the best example for non-uniform steady flow. So whenever the storage of, whenever the floods is coming, whenever the dam is present in rivers, so the backwater surface profile at upstream of the dam is the best example for non-uniform steady flow. Rapidly varied flow. So coming to the rapidly varied flow and gradually varied flow, whenever the channel, within the short length, the variation is occurred, such type of flow is known as rapidly varied flow. So within the short length, the flow is going to vary. So rapidly varied flow is defined as that flow in which depth of flow changes abruptly over a small length of the channel. So within the short length of the channel, the flow is varying rapidly. Already I told in first slide, the name, once we understand the name, the terminology which is relevant to the definition, that gives something. The definition is in the term. So rapidly varied flow. Rapidly, it means fastly. And within less length, within the less time. So these are all comes under rapidly. So rapidly varied flow, the flow changes within the short length. Within the short length of the channel, the flow is going to change. So that is nothing but the definition of the rapid varied flow. When there is any obstruction in path of flow of water, the level of water rises above the obstruction and then falls and again rises over a small length of the channel. So the depth of the flow changes rapidly over a short length of the channel. This is the one of the example for understanding. If any obstruction is there in the path of the flow, so the flow is going to rises and again it falls and again it rises. So within the short length of the channel. So this is the depth of the flow changes rapidly over a short length of the. For this short length of the channel, the flow is called rapidly varied flow. Coming to the gradually varied flow, gradually. So if the depth of the flowing channel changes gradually over a long length of the channel, it is gradually, rapidly, like this. Gradually, whatever it, whether it is rises or falls, gradually. So here there is a rapidly is like this. Coming to the gradually, rapidly varied flow, gradually varied flow. If the channel bed is like this, so some any obstructioner is there, so the flow is like this within the short period, otherwise like this. This is rapidly varied flow. Coming to the, this is the bed of the channel bed, gradually varying the flow. This is the difference between these two, and the name itself tells the difference in the open channel flows. So gradually varied flow. If the depth of the flowing channel changes gradually over a long length of the channel, the flow is said to be gradually varied flow, and it is denoted GEF. Rapidly varied flow, RVF. Classification depends upon the Reynolds number. Based on the Reynolds number, we are classified the open channel flows. So whenever the Reynolds number is equal to rho VR, in this V is the mean velocity of flow of water, R is the hydraulic radius or hydraulic mean depth, and rho and mu density and viscosity of water. Density and viscosity of the water. This is the Reynolds number. Based on these Reynolds number, we are going to classify the flows. So whenever coming to the open channel, in open channels, the Reynolds number is less than 500 or 600 sometimes. So 500. Generally, in most of the cases, we are considering 500, sometimes 600. So Reynolds number is less than 500. Such type of flow is known as laminar flow. Laminar flow. So this is the Reynolds number. These are the characteristics or parameters we are using for how much the Reynolds number is there. This is the formula we are using. These are the parameters. Rho VR. Density, hydraulic radius, and velocity of flow of water. These are the parameters we are using for identifying the Reynolds number. If the Reynolds number is less than 500, such type of flow is known as laminar flow. If the Reynolds number is more than 2000, such type of flow is said to be turbulent flow. Such type of flow is said to be turbulent flow. In between these two, 500 to 2000, the flow is considered to be in transition state. Transition state. So this is the classification which is based on Reynolds number. So coming to the difference between open channel and pipe flow. So physical conditions, coming to the physical conditions in open channels, very much more than in pipes. The cross section of pipes is usually round, but for open channels it may be any shape. Coming to the pipe channels, we most of the 99% pipe flow, all the pipes are circular, rounded shape. So but coming to the open channels, it can be any shape. It can be rectangle, trapezoidal, triangle, circle. And the next another difference between these two, treatment of roughness also poses a greater problem in open channels than pipes. So the roughness Although there may be a great range of roughness in pipe from polished metal to highly corroded iron, open channels may be of polished metal to natural channels with long grass and roughness that may also depend on the depth of the flow. And also, open channel flows are found in large and small scale. Open channel flow is driven by gravity rather than by pressure work as in pipes. So in open channels, the driven may be done by gravity. It depends upon the channel bed, also sometimes the slope of the channel bed. In pipes, it requires pressure. Despite the similarity between the two kinds of flow, it is much more difficult to solve problems of flow in open channels than pipes because the conditions are more. Flow condition in open channels are complicated by the position of the free surface, which will change with the time and space, and also by the fact that the depth of the flow, the discharge and slopes of the channel bottom and of the free surface all are interdependent. These are all interdependent. In open channels, it is somewhat difficult to solve the problems when compared to the pipe flow. Why? Because we have to understand the free surface, which is going to change along with the time and space, as well as discharge, depth, slopes of the channel bottoms. Those are all, and also free surface, these are all interdependent. So flow driven, pressure work, gravity, potential energy, these are the differences which is shown in this table. Cross sections, pipe flows known and fixed. Coming to the open channel, unknown in advance because the flow depth is unknown. Coming to the flow, pressure is work. So pressure is required in pipe flow. Coming to the open channels, it is driven by gravity also. Coming to the flow cross section, it is fixed. Coming to the open channel, the flow depth is unknown. We don't know in advance. Characteristic parameters, flow velocity detected from continuity. Coming to the open channel flow, flow depth detected simultaneously from solving both continuity and momentum equations. Here we required momentum equations also. Pipe flow, specific boundary. So there is no, not required. Atmospheric pressure at conditions the free surface. This is the specific boundary. So the atmosphere, the free surface, whenever the free surface is relevant to the atmospheric pressure. These are the major differences as per the different parameters point of view in open channel and pipe flows. So coming to the one more important topic. So till now what we understand, what is meant by open channel, what are the various classification depends upon the parameters. Now we are coming to the discharge through a open channel by Cheese's constant. In this figure, the figure shows the datum line. This is the datum line, uniform flow. Here we are considering uniform flow of water in a channel which is shown in figure. As the flow is uniform, it means the velocity, depth of flow and area of flow will be constant for a given length of the channel. We know the definition. Uniform flow means the velocity, depth of the flow and area, the cross-sectional area of flow will be constant for a given length of the channel. This is the given length of the channel L. Given length of the channel L, and this is the datum line. This is this dotted portion. The dotted portion. This is the datum line. Consider cross section at section 1-1 and section 1-2. In between, this is L, length of the channel. So this is the flow of water. This complete is the flow of the water. Here in this, L is the length of the channel, A is the area of the flow, I is the this is I, slope bed, V is the mean velocity of flow of water, P is the wetted perimeter, F is the frictional resistance per unit velocity per unit area. F is the frictional resistance. These are all the parameters we are going to consider in this. I is the slope bed. This is the I. So now we are finding discharge through open channel by Cheese's constant. So these are all the parameters. So in this, the weight of water between section 1.1 and section 2.2. Coming to the section 1.1 and section 2.2, weight of the water. So the weight of the water between two sections. Weight of the water is equal to specific weight multiplied by volume of the water. So coming to the specific weight, that is nothing but the specific weight multiplied by volume, area into length. Similarly, the next one is component of W along the direction of the flow. This is the component W along the flow, and this is W sin I. This is the I. This is W. So now component of W along the direction of the flow. The component is like this. The flow is like this. So in this, the flow is like this. The W component is like this. The flow is like this. This is W. So now W into sin I. So substitute the value in this. This is the thing we get. Frictional resistant against motion of water. Frictional resistant for this subject, prerequisite of fluid mechanics is required. So we know frictional resistant against motion of water is equal to F into surface area into velocity. So the value of N is found experimentally equal to 2 and surface area is equal to P into L. So now the frictional resistance is equal to F P into L into V2. Velocity into 2. The forces, these are the components we consider. What are the forces acting on the water between the section 1.1 and section 2.2? Component of weight of water along the direction of the flow, frictional resistant against flow of water, pressure force at section 1.1, pressure force at section 2.2. So these are the forces acting on the water between the sections in 1.1 and 2.2. What are the forces? Component, weight of the water along the direction of the flow. This is the component. And this is the component weight of water along the direction of the flow. This is our direction of the flow. So along the direction of the flow, how much the component water along the direction of the flow? Frictional resistant against the water, pressure force at section 1.1 and pressure force at section 2.2. These are the forces acting on the water in between section 1.1 and section 2.2. In case of uniform flow, the velocity of flow is constant for a given length of the channel. Hence, there is no acceleration acting on the water. Hence, the resultant force acting in the direction of the flow must be 0. So, as we know, we are consider it is as a uniform flow. In uniform flow, the velocity of flow is constant throughout the length of the channel. It means there is no acceleration acting on the water. Hence, the resultant force acting in the direction of flow must be 0. So, resolving all the forces in the direction of the flow, we will get WAL sin I minus FPL V square. So, we are considering N is equal to 2 as experimental. Now, we are doing the calculation. WAL sin I minus FPL V square is equal to 0, equating both WAL sin I is equal to FPL V square. Now, V square is equal to, cancel all the thing, the remaining thing is WF by AP by sin I. Okay, This is the final component we are getting. This A by P is, now we know A by P is equal to area by perimeter is equal to mean depth or hydraulic radius. So now root W by F is equal to C. This is nothing but the Cheese's constant. Cheese's constant. Substituting all the values of AP and WF in equation, finally we will get V is equal to C root M sin I. Sin I. For small values, sin I is equal to tan I is equal to I. So finally V is equal to C root M I. This is the velocity. This is the velocity. So now coming to the discharge. Discharge is equal to area into velocity. We know Cheese's based on the Cheese's constant, velocity V is equal to C root Mi. So A into C root Mi. Where A is the area, C is the Cheese's constant, M is the hydraulic mean depth. Here M is nothing but the A by P. A by P. I is the slope. This is the discharge through a open channel by Cheese's constant. Final value Q is equal to AC root Mi. So this is the end of the lecture. So next class we will go for the numerical model, and remaining topics we will discuss in our next video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.